Hi, this is Matt Ratliff from the Autodesk Product Support Team, and today we're going to talk about perfect blend techniques. As an overview, we'll be covering a workflow for modeling freeform or styled fillets to a theoretical intersection. We'll explain exactly what is a theoretical intersection, and we'll review traditional tools typically used for these types of fillets and blends. We'll then demonstrate a method for building a blend using several tips and tricks. The resulting fillet will contain a logical CV and hull structure and will provide the ability to make very fast design changes. So to start off this first section, we'll cover using two tools you may already be familiar with. One of them being Freeform Blend, and the other being Surface Fillet with the variable radius option. Some key learning objectives for this section are we're going to show exactly what is a theoretical intersection, and we're also going to show in the traditional methods, you'll find that they're not always easy to change, and the resulting CV hull structure is not always desirable. So what we have here are two sets of surfaces. The red set of surfaces is actually a copy of the black set of surfaces, but it's untrimmed to show the theoretical intersection. So anytime you have a set of surfaces that intersect like this, and you would actually build your fillet along this intersection, that is a theoretical intersection. So with that said, let's take a look at the black set of surfaces. I'm going to isolate that by using hide unselected. And let's say you want a fillet boundary or a blend that looks like this example, where you have a large fillet that tapers down to a small fillet. But if you notice, it's not a complete variable radius where it's equal on both sides, but if you notice, the top has more of a stylized line to it, or a stylized boundary. So traditionally, I can use the Freeform Blend or the Surface Fillet to build this blend. So the Freeform Blend is located in Surfaces, Multi-Surface Blend, Freeform Blend. And I already have these options set to curvature. And I'm just going to go ahead now and pick my boundaries that I want my blend to be built. So there's our resulting blend. So for the purposes of this demonstration, we're not going to go into using explicit control and minimizing the math or the spans or degree of these surfaces, but we're going to leave them as is. So if we take a look at the CV and hull structure here, notice how the interior parameterization is pretty good. So they flow with the slab surfaces. This is because in the flow control, I have edge align options turned on. If I turn off the interior edge align, you'll notice that this interior will become slanted. And this is not a desirable situation. So after taking a look at the CV layout here, let's just do a quick shade on this surface. And I have to make a note that I recommend using the ISO angle tool for a lot of your evaluation techniques, but for the purposes of this section, we're just going to go ahead and use the default diagnostic shading. So if you notice here, as I start to kind of pan and move over this, you'll notice that first off, even though it was set to curvature, that there's a small break right here. And I'll just use one of the tools here to illustrate that. So right here you'll notice that there's a small break in there, and that's definitely not desirable. Also, if you notice, as we start to move and tumble around here, notice that there's a dip in here in this region. So we definitely don't want that as well. And we can confirm this by looking at some of the other diagnostic shading, and you can just tell that definitely along these boundaries here that you're going to have kind of a break in there, and that's not something we want. So another method that we're going to show is using the surface fillet to achieve this. So what we're going to do is we're going to go back to our red data set, and surface fillet requires that you have a set of surfaces that have a theoretical intersection, which we have here. And we're just going to go into Surfaces, Surface Fillet. And I already have it set as a chordal fillet. I'm going to turn off my variable fillet. We're just going to show the default fillet, what you would typically get. So this is a default fillet, but in our previous example we had more of a stylized blend. And if we want to do something like that with a surface fillet, we can turn on the variable radius fillet. And what we can do is maybe try to mimic something like that previous example. So in that, what we're going to see here is you're not really getting the same result, because the variable radius is actually going to equally create that situation. And if you go back to our comparison here with our black set of surfaces, you'll notice that it's not quite an equal variable radius situation. So this bottom tangent line is kind of has a small taper and it's mostly the same, whereas the top has most of what's happening on the surfaces. So I'm just going to undo that, and we'll go ahead and proceed to section 2. In this section, we're going to show how blends are sometimes built manually. So curve-on surfaces are defined. Usually the surfaces are trimmed out, and a blend is built manually in between those two tangent boundaries. So we're going to show in this section how tools such as Tubular Offset are sometimes used to define a curve-on surface. So what we have here is the data set from section 1. So if we want to build a fillet or a blend in here along this theoretical, we do have some traditional methods that we can use to do this. One of them we reviewed in section 1, which was the variable radius surface fillet. The other one was Freeform Blend. And now we're going to use Tubular Offset to set our radius in here to get a curve on surface. Once we have a curve on surface, we can trim the surfaces back and build our blend. So Tubular Offset is located in Surfaces, Rolled Edge, Tubular Offset. And under the surface rollout, there's several options that you can use within the tool. And for this demonstration, we're going to use none. We don't want it to actually create a surface. We just want to set it to curve on surface. And I have my chain select on. I'll just select the surface, and it highlights the theoretical. Now the interactive manipulator allows me to change the radius. So now I have a curve on surface that defines that boundary. And I can do the same thing on the top, and I can also have it differ from the bottom. So this is one of the traditional tools used to build a curve on surface or assist in building blends. So in section 3, we're going to start getting to the subject matter of this workflow video. We're going to demonstrate and discuss starting a blend from a design curve. And that's going to look similar to the blend that we showed in section 1, where we have a large fillet tapering to a smaller fillet. Some key learning objectives for this section is we're going to be reviewing the extend tool as a method to use as a surrogate surface for building the blend's boundary curves. And then we're also going to go ahead and project the curves onto the surface in preparation for section 4. Okay, so what we're going to do is we're going to switch to a different data set now, and it is provided with the knowledge base video, and it's section 3 _ extend.wire. So what you'll notice loading this data set up is that we have a couple surfaces here and a surface on the top that are intersected to form a theoretical intersection, and we're going to build a blend in here. And you may have a designer, or you may be the designer that is wanting a blend to flow like in section 1. So what we have in our top view here is a line a quick line that indicates as a sketch here exactly how we want our blend to flow. So one of the things is we want to create some curves that are going to define our blend boundary. Typically we would use a curve on surface to show this, but in this workflow we are going to eliminate curve on surface data. We're not going to build to curve on surfaces. Curve on surfaces sometimes make data unnecessarily heavy, so we're going to show a workflow that's going to eliminate that. We are going to use curve on surface data as a guide that we're going to build our curves to, but we'll get to that a little bit later. So right now we're going to go into our extend tool, which is an object edit extend. And if you go in the options for this tool, we've got linear and extrapolate. We're going to leave it in extrapolate. we're going to turn merge off. We want our surface to be separate from our original slabs. And we're also going to turn chain select on. So I'm going to hit go, and I'm just going to pick my draft surface, and we're just going to bring the surfaces down here somewhere, because this is going to define the bottom of where our fillet boundary is going to be. So go ahead and pick nothing. So now I have two extend surfaces in here that are extended down to there. So now what we're going to do is we're going to go into our curve edit, create and duplicate curve, and we're just going to duplicate a curve on those edges. And then we're going to go ahead and delete those extend surfaces. So in essence, we use the extend tool as a surrogate surface to duplicate these curves, or to build these curves that define our boundary. So we're not using a curve on surface here like we did in previous sections. So now these curves that are created, we know are created exactly on these surfaces here, because we use the extend tool, extending these slabs down to build those surfaces, or those curves. So now what we're going to do is the same thing in the top view. We're going to go into our extend tool, and we're just going to go ahead and extend this plane down, and we're just going to try as best as possible to match up what we're seeing here in this curve. So what I'm going to do is I'm going to change this extend to a 5-degree surface. And then what I'm going to do is I'm going to go ahead and use my move tool and use our slide CV tool. And we're just going to kind of move those down to match. So now what we're going to do is we're going to go ahead and go into our curve, edit, create, duplicate curve again. And obviously this could be placed on your marking menu. And we're just going to go ahead and duplicate the extend. And same thing, delete our extend tool, or our extend surface. So now we have a curve that lies exactly on that surface. So in this section, we're going to project our curves down to the surfaces, or the slabs, and we're going to use the align tool to match up the curve to the curve on surface. The curve on surface is going to be used as a guide to verify that the curves that we created in the previous section that we used with the extend tool are actually lying directly on the surfaces. Then we're going to measure the resulting deviation of the curve to the curve on surfaces. And we're also going to demo a trick using the align tool to minimize the deviation. So in this section, what we're going to do is we're going to go ahead and project our top curve that we created in our previous section onto this top surface. So I'm just going to hide everything but what I need. I'm going to go ahead and go in the top view, and we're just going to do a standard project. So I'm going to pick surface. I'm just going to use project. So the reason for doing this is we know that the curve on surface lies directly on our top slab here, and we want our curve to lie directly on that top slab. So what we want to do is we want to check and see how close our curve is to the curve on surface. So to do that, we're going to use a curve deviation. So I'm just going to pick both of those. We find out our deviation is 4.246, which is definitely out of tolerance. So we're just going to zoom in here, and I'm just going to, as you can see visually here, that the curve looks like it's not even close. So I'm just going to pick CV and use a move, and I'm just going to snap that CV onto the curve on surface. So now our deviation is more like 1.1556. So we're going to want to even get closer than that. So what I'm going to do is I'm going to go ahead and just zoom in really close here. And we know that our curve on surface lies right here, and our curve lies right here. So what I'm going to do is I'm going to use our Align Tool 2008, and what I'm going to do is I'm just going to pick the curve on surface, and what we're going to do is just align our curve to it. Now since we don't want 205 spans, we're going to change that back to default. And when I zoom out here, you can see that the tolerance is now or I'm sorry, the deviation is now 0.0539. So now we're going to show a little bit of a trick here. So in the Align tool 2008, if I click Accept, and then I go in here, I'm going to hit 5 again, 5th degree. You notice now the deviation's changed to 0.04. I hit Accept again. I'm going to put in 5 again for the degree. And notice how each time I put this in here, the deviation goes down. So what we're going to do is we're just going to keep doing this until our deviation gets low. Let's say to 0.001. And in the next section, we'll continue with our deviation already set. Okay, in this section, we're going to delete the curve on surface data that we use as a reference. And we're going to discuss a little bit about the parameterization of the curves and how the theoretical is. So some key learning objectives for this section are, we're going to be matching up the curve in Blend's parameterization to the theoretical by using curve section and extend. So in this section, what we're going to do is we're going to delete our curve on surface data so that we're left with the two curves that we've duplicated off the surrogate extend, as well as the curve that we've aligned to the curve on surface on the top. So we'll just go ahead and delete our curve on surface here. And then what we're going to do is, I should make a note that when we actually did the align trick in the previous section, that it took quite a while to get our deviation down on this. And also, I had to change to a 7th degree curve rather than a 5th degree curve. And that left me with a deviation of 0.001. So with that said, we'll continue on. And what we'll use is the duplicate curve tool again to duplicate our theoretical. And now you'll see from a parameterization standpoint, if I switch to this view here, what you'll notice is we have a curve here that's a 7th degree, a curve here that's a 2 degree, and so on. So the way that they're split, what we should do is split this top curve here if we want the parameterization to flow properly with the slabs. So in order to do that, we're going to use our extend tool again with merge off. And what we're going to do is we're just going to extend this over. Now keep in mind that you can use the snapping functionality, so I am going to snap it to that line. Then what I'm going to do is I'm going to go into the curve edit, curve section. Typically by default it might be set as the trim option, but we don't want to actually trim the curve. We want to segment it. So we're going to go ahead and hit go. We're going to click our curve, hit enter, and then click the edge of our extend. So we used our extend to show a vector that we're going to use to trim this curve off. So now what we're left with is the curves like that. So to keep the parameterization the same, we want to make sure all curves are the same degree. So what I'm going to do is I'm going to go in here and just change all these to the same degree. That's a 7. We're going to change this guy to a 7th degree. And same with that guy. So now what we have is we have an even parameterization on all of these curves here. In this section, we're going to finish up our blend surface by using the curves that we've built from the previous sections. We're going to use the skin tool to build the blend surfaces, and then we're going to use the proportional modification tool to snap the surfaces to the theoretical line. Okay, so now that we have our boundary curves built, let's just go ahead and select them. We'll do a hide unselected. We'll go ahead and turn off all the CVs and hulls except for our theoretical line. So now what we're going to do is we're actually going to build our surfaces in here to direct model with. So I'm just going to put some simple skin surfaces in here. And we'll do this on both slabs here. Now what we're going to do is just go ahead and turn on our continuity indicator. We have curvature in between the skins, and we'll just turn on our CV hull structure there. So now we have a CV hull structure that's flowing with our theoretical. So now what we're going to do is just going to add another degree in here to give some more control when we do our direct modeling, just to make sure we achieve the proper continuity levels. So now what we're going to do is we're actually going to do our direct modeling. So be sure that your CV edit point snap is turned on. And then we're going to go into Transform, Modify, Proportional Mod. This is the tool that we're going to use to do our direct modeling. We're going to have our preceding and succeeding V values or negative V values set to 1. Then what I'm going to do is I'm going to pick this CV, this middle row, and snap it to the CV on the theoretical. And I'm just going to keep doing that as we go all the way across the surface here. And what you'll find is you'll lose continuity in between those surfaces, but as you start to snap your CVs, you'll automatically achieve your continuity back. And I'm just going to continue here across my blend surface, and that's it. So now we've built our blend. I'm just going to pick my blend, go ahead and delete my locators, and I'm going to create a new layer just for organizational purposes and assign our surface set to it. We'll go ahead and bring our original data back, and because we still have our surfaces untrimmed, what we're going to do is we're just going to project our new boundary edges onto those surfaces. So I'm just going to go into top view here, and I'm just going to project our skins that we just created. We're going to project those down. Then we're going to trim that out. I'm just going to hide unselect that on everything but the surfaces to make this easier. And I'm going to do the same thing on the bottom row. Okay. So there we go. But if you do a continuity check on here, we're probably not going to have continuity. So what we're going to do now is we're going to use our new Align tool. And in the new Align tool, we're just going to set it to a project alignment type, curvature with explicit control. It helps to delete your locators beforehand, and what you can do is set to show locators within the tool. So I'm just going to do an alignment there. We're going to specify a continuity of curvature. And we'll add a little bit of math there. And we're good. And I'm just going to do the same thing on the top and bottom. So there we have our blend built. So this is a very nice method of building our blends, and it's a very quick and easy way, and we're guaranteed great results because our final surface flows with the theoretical. In our next section, we're going to go ahead and work on evaluating this surface. Okay, in this final section, we're going to evaluate the blend that we built in the previous section using our direct modeling techniques, and we're going to compare that to some of the other traditional surface construction techniques that we discussed earlier on in previous sections. Okay, so now we're just going to do a quick comparison of some of the traditional methods that we discussed earlier, which would be the freeform blend, the surface fillet, and then our technique that we discussed using the proportional modification tool. So to start, I just have our freeform blend surface here, and what we're going to do now is first off, I'm just going to go ahead and create some quick combs on it here. And first thing that it's worth noting is you can see in the curvature combs where it comes across and dips down that there's an inflection in the surface set here. So this would be consistent with what we see if we do an ISO angle evaluation on this surface. And what you're probably going to see, so right there you can see that there's definitely where that little black spot is right there, that's going to be a dip or a pit in the surface. So you can see right now as I start to move this ISO angle here, as the highlights start to move, you can see there's a pit in there. So there's a little bit of a valley and there's a little bit of a peak from just doing a quick evaluation. And then typically I'll also go in and just take a look at how it looks with the diagnostic shade, and you can see definitely that there's a little bump in the surface there. So we'll go ahead now and move on to our surface fillet. And with the surface fillet tool, there's going to be a cleaner highlight flow, and there's also going to be a cleaner curvature flow with the curve combs here. So that's one thing to notice. So that's one advantage of using the surface fillet tool. One of the disadvantages, however, is if you notice, if you look at the tangent lines here that's created with this variable radius fillet, if you look at that, what you'll notice is that they're the same on both sides. So if we want a fillet that has a different tangent line on, say, the bottom, or some type of stylized blend or fillet situation, the surface fillet tool is probably not going to be the best option. So now that brings us to our proportional modified skin surfaces here that we use to snap to the theoretical. So the first thing to note is that these surfaces are single span surfaces, and I'm just going to go ahead and put the combs on them just like the other surfaces. And what you'll notice is we have a nice clean highlight flow, or curvature flow I should say. Go ahead and clear those out. And I'm just going to do a quick ISO angle on this surface. And what you're going to see is you're going to see more consistent highlights here that you didn't see on the previous surfaces here. So it's good just to kind of use this to see if there's any breaks or any issues with the surface here. And what I'm seeing right now is a nice clean highlight flow through the surfaces. So this is a great method to get a nice clean, not only conceptual surface, but it's a great downstream surface that can be sent to another user or to engineering for future development. Okay, to summarize, we've showed some traditional methods that are commonly used to construct fillets and freeform blend situations using a variety of tools. We've showed how to use extend as a method for building curves that lie directly on surfaces, as opposed to using projected curves and curve on surface data. We've showed a trick using the align tool to minimize deviation in previous sections. And we've done our direct modeling of blends using the proportional mod tool to build quick blends to a theoretical intersection.